Hi, this is Boshi. Today I want to talk about the first question of the homework 11. For the homework 11, there is two parts. It said the stochastic process xt is real WSS with autocorrelation shape Rxx and power spectrum density Sxx. Showed Rxx is real and even and Sx is even and non-negative. So for the first part A, from the question it said xt is real WSS, so we can get Rxx equal e to the xt plus this one times xt is real, because xt is real WSS. For the Rxx, for the even part, we need to prove Rxx for this one is equal to Rxx to the negative part. So for this one, we need to write it out, Rxx t plus this one and t, which is equal to e to the xt plus this one and xt. As we know, we can exchange these two parts, so which is equal to xt and xt plus this one, which is equal to Rxx t and t plus this one. So for this part is equal to Rxx of negative part. So we can prove that it is even. So this is for part A. For part B, they want us show Xx is even and non-negative. So at first I want to show it's even. Same idea as this part, we need to prove Sx equal to Sx for the negative omega. So for this one, which is equal to infinity to negative infinity, Rxx times e to the g omega, this one, which is equal to, because it can be a complex part of function, so we need to write it to two parts, and the minus because it's negative, so it's minus g to the infinity to negative infinity xx times sine omega to this one. So this is the equation for this, this is the equation for this part. As we know, this part is an even function and this part is odd function. So when we times even and odd together, which is equal to odd function, so this part just odd. So which is equal to, we can ignore that part, so which is equal to infinity to 0 times 2. I make it infinity to negative infinity to 2 parts, which is times 2 because it's same. From infinity to 0 and 0 to negative infinity times cosine omega d. And this part can be equal to this one for the negative part. So which is equal to Sx for negative omega. So we can prove it's even. For the last part, for non-negative parts, I want to use the idea from the lecture note, which is xt h omega and yt. So as we know, h omega equal to square root of 2 pi times omega minus omega 0. This is a single frequency pass filter, and when we get square of it, which is equal to 2 pi times omega minus omega 0. we will use this part below. And e to the absolutely yt square, which is equal to 1 divided by 2 pi infinity to negative infinity of h omega square times sxx omega times d omega. So which is equal to we can separate this one to 2 pi times omega minus omega 0 times sx omega times d omega. So this one just directly equal sx to omega 0. Since e to the yt square is this one is bigger than 0, because from this part because this one is bigger than 0, so this part is also bigger than 0, so we can get s omega bigger than 0, bigger or equal than 0, so it is non-negative.